So your brow rig needs to be able to grab the brow and move it left and right. This is a little extreme in that area, but just a demonstration, as well as up and down. This crease, though, between the eyelid and the eyebrow, you want it to move up and down in a sort of rotational path around the eyeball, but you don't want it to be moving left and right at all with the brow. So instead of moving like this, you'd want it to be locked off. Kind of like this. But you do want it to follow when it moves up and down. So how are we going to do that? So I'll jump into another file that's a little more simplified, and we'll go over how we can do that. So here we have a simple mock-up of a face using curves instead of meshes to keep things simpler. So we've got our eye here, we've got a representation of the crease, and a representation of our horizontal brow. And so here we have a point on the curve, represented by a red locator, and we want it to follow this curve up and down, but not left to right. So we want it to stay fixed along this pink curve, but still follow along with this one. So basically we want to get the intersection between this curve and this curve. And we can actually do exactly that. So let me open up the node editor and create a curve intersect node. And we will plug in the world space attribute from this curve. And the world space attribute from this one. So now it is trying to solve for the intersection between those two curves. And the output is a parameter value. So we'll use a point on curve info node to take that parameter out. Whoop. And this is parameter 1, which means it's the parameter on curve 1. So we'll take world space, that curve, plug it into here, and then we can take the output, but we already have a locator. Take the output from that and plug it into the translate of this locator. And you'll see that it jumped here to the center instead of jumping here where the two curves intersect. The reason for that is if we go out of this flat view into 3D space, those two curves actually don't intersect in 3D space. They appear to when we look down the z-axis. So what we can do is go into the curve intersect node, turn on use direction, and then change this vector to the z-axis. And now it snapped onto that point just like we wanted. So now when we move this up, minimize that, we move this up and down, you can see it follows, and even if we move it left and right, it only moves up and down with the curve. So you probably saw something jump up when we were doing that. Here in the output window, you can see we're getting a cycle warning. The reason we get that warning is because the curve intersect node is a little bit buggy. Even when you're using it properly, it gives you a cycle warning. In the most recent version of Maya 2018, which I think is Maya 2018.4, at least at the time that I'm making this video, this bug doesn't occur unless you have your execution set to parallel. Parallel triggers the bug again. So we need a workaround because we don't want that warning to be happening. So let's disconnect that curve intersect node, go back into the node editor, and delete it. And now what we need to do is build a different system. So what we're going to do is we're going to take this curve, create a transform geometry node. Oop, that's not a transform geometry node. Connect in the world space. And then create a compose matrix node. Plug it into there. And we're going to scale that curve down in the y-axis, so it's flat in the plane, and then also in the z-axis as well. So it only has length in the x-axis. So then we'll create another nurbs curve and plug it in. And I'm going to turn on the CVs for that curve, as well as this one. Oop. So that you can see that it is in fact flattening that curve. So see how it didn't move up with this curve, even though we're plugging into that? That's because we flattened it with the transform matrix node. But if we move left and right, you can see that the CVs down on that bottom curve move left and right with it. So now we want to find the corresponding point on this curve that would be associated with this locator, or more specifically with this x position. So we're going to create a locator, move it right here, so it's at the same point on the curve, well, the same point on this lower curve as this locator is on the upper curve. Then we're going to take this locator, create a nearest point on curve node. So we're going to be going from the position of that locator to a parameter value on that curve. And then we're going to take the parameter from that nearest point on curve node and use it on the upper curve, the one that actually does move up and down as well as left and right. So we'll do a point on curve info node. Take the resulting parameter from here and plug it in. Take the world space from there, plug it in there. And then grab that locator, bring it up here, grab its position, plug it into translate. And so I'll kind of lay this out so it's clearer. So what we're doing is we're taking that curve, flattening it to create this flat curve. Then we're taking the x-coordinate of that locator in the form of this locator, using a nearest point on curve node to convert from a position to a parameter on that flat curve, and then using that parameter to find a point on this brow curve, and then plugging that in to the locator. So let's see how that works in 2D space. You can see that it's moving up and down, and when we move left and right, it stays the same. Even if we do something really strange like this. And if we look in this view, you can see that it does follow movement in the x-axis. So it's only been locked out in this single axis. Now there are some limitations to this, just like there are for the curve intersect node. If I were to take the brow and move it all the way over like this, there's no longer a valid point where these two intersect. If we were using a curve intersect node, this would just jump right back to the origin. But by using this one, it gets the closest point on the curve to where it would intersect. So it's a little bit more stable in that way. And of course, it's a lot more stable because we don't get constant cycle warning. So now, if you were to set this up on an actual rig, you'd have joints along this curve for the brow, and then you have a second set of joints along this same curve, but only following its up and down motion. And that's what you would bind, well, you'd skin to this crease region of the mesh.